Hello and welcome to another Edexcel iGCSE Computer Science Past Paper question. This is November 2021. At the time of filming this video, this is the latest paper. The video was filmed in April 2022. This is paper 2, Application of Computational Thinking. So this is the practical paper. This is the 3-hour practical paper. Total marks out of 80. So in your exam, you will get this paper. You'll write on this paper, but you'll also be given some files to go with the exam that you will need to use, either Python, Java, or C#. So first thing you're going to do here is tick whichever language you're using, and in this case I'm using Python. So do make sure you tick or cross the right box. In this case I'm using Python. Now I'm ready to start the paper. So question 1a. Programmers write code to solve problems. Give one technique that programmers use to make their code easy to read and understand for 1 mark. Now there's many things that we can write here, which I'm sure you do in your code. We can have comments, indentation, white space, but I'm going to go with comments. We would comment the code to make it easier to read and understand. And because it's only 1 mark, that's all I'm going to write. You don't really need to write full sentences there, just for 1 mark. We'll scroll down and look at B. Programs may contain logic, syntax, or runtime errors. Program has 3 errors. They may be logic, syntax, or runtime errors. Complete the table by adding a tick for each error description to show whether error is a logic, syntax, or runtime error. I'm just going to grab my tick there, so you must put a tick in there. So divide by 0, I'm going to place my tick in there. That is a runtime error. I'm just going to move it down a bit like that. Use X instead of star to multiply. That's a syntax error. And subtract 10 from 2 instead of 2 from 10. That's a logic error. So remember, runtime error is, for example, it was expecting to find a file and didn't, or divide by 0. Use X instead of star, that would be a syntax error, that's user error typing, and subtract 10 from 2 instead of 2 from 10, that's a logical error. 1c, figure 1 shows a programming construct in a flowchart. Start, and then you've got the diamond shape. From that you've got yes, no, and stop. Identify the name of the programming construct. So here we've got a choice: array, iteration, operator, or selection. The answer is D, selection. So that diamond shape is selection, also known as decision, and there should only be 2 outputs from that, yes or no. D, open Q01D in the code editor. So this is Q01D that I've opened in idle. There are 3 errors in the code. Amend the code to correct the errors and save it as Q01D finished. So first thing to do when you get a question like this is to immediately save it. So we'll save it as Q01D finished, and make sure you save it in a suitable folder, because at the end of the exam, what the examiner is going to do is take all of those folders, and that will be what will be sent off to the exam board. So you must make sure that they're all in the correct place and they're all named appropriately, which is Q01D finished with capital letters. So you might be able to immediately spot, for example, there is a syntax error, and we can immediately fix that. That's one of the errors, but some of them might be a little harder to spot, and the way around that is just to simply run the program. So we run the program and then we let idle tell us where the errors are, so invalid syntax. So what's wrong with this then is if number 1 is supposed to be, if number 1 is equal to number 2, then numbers are equal. But instead of doing that, it's assigning number 1 to whatever is number 2, and instead of a single equal sign, we need a double equal sign to fix that. So then we have our operator there, if number 1 is equal to number 2. So run it again, saving it, and we should get our second error. So it's the first number. Now this one's a little harder to find, and this is actually a logical error. You could easily get this one wrong in the exam and just assume because you've got blue writing there that it works. Yeah, it's fine, and you're only going to get 2 marks. Then you're going to lose another mark, and every mark is important. If we read that, the highest number is 4 and the lowest number is 5. That's not right, is it? So that is what we call a logical error there. So we need to go and have a look at this. So if number 1 is greater than number 2, the highest number is number 2 and the lowest number is number 1. Now, is that right? So perhaps we'll change that symbol to less than. So if number 1 is less than number 2, the highest number is number 2 and the lowest number is number 1. So we'll run that and see what happens. And now we'll test it again with the numbers 4 and 5. So enter the first number 4, second number 5. The highest number is 5 and the lowest number is 4. That works, okay? So just simply changing that comparison there has given us the right answer. What that's saying is number 1 is less than number 2, then the highest number is number 2, and the lowest number is number 1. Otherwise, the highest number is number 1 and the lowest number is number 2. So we'll test it again. We'll try different things now, okay? So enter first number 5, and this time we'll enter 4. Highest number 5 and lowest number 4. It works, okay? So I've saved that as Q01D finished. I closed that. That's in the right folder. I know I've got my 3 marks there. E. A program is needed to calculate and print a multiplication table for a number that is input by the user. So times tables. So e.g. number 2 is input, 1 times 2 is 2, 2 times 2 is 4, etc. So this is what you're given for this one, and just have a look how many marks is this worth. Just scroll down. This is 5 marks. So creating a program for a multiplication table. So here given comments as to where everything must go, and you must write the correct code within those comments there. Print prompt get number from user. So number equals int input. Please enter the first number, or please enter the number. Okay, it's not the first number, it's the number. Now don't forget to close 2 brackets. Make sure it's an integer input. If we don't specify there, it will automatically default to a string, and you won't be able to do anything with that in terms of maths multiplication. We don't want it to be a float because I don't want it to be a decimal point number. I just simply want an integer now. Okay, so that's probably maybe 1 mark. Now I need to create a loop to display the table. So what's got to happen is, to run it, it's got to display 1 times 2 is 2, 2 times 2 is 4, etc. all the way through. So I'm going to use definite iteration here. So I'm going to use a for loop for I in range. What's my range? 1 to 13. So that'll loop around 12 times. Don't forget the colon there. Now we're going to print out our output, print. So we're looping around I, okay, times number is, and it needs to be in a sentences, so we use commas to separate the values here. I times number I input, so 1 times 2, 2 times 2 is, now I need to do multiplication, I star for times number. Okay, let's save that as Q01E finished and run it. So now the moment of truth, let's do the 2 times table. So 1 times 2 is 2, 2 times 2 is 4, 3 times 2 is 6, all the way down to 12 times 2 is 24, and that works. And that's absolutely fine. It's absolutely what we want to do there. And that's going to get me, that looks like the output there that I was supposed to have. That's going to get me my 5 marks. And that completes question 1 for a total of 13 marks. 2. Estelle is learning about searching and sorting algorithms. Estelle's friend has given her a partly completed program to carry out a binary search. Pseudocode contains the logic required to complete the program. Now, in case you're not sure what a binary search is, I'll leave a link and the icon above to a video where I've covered this. You must make sure you understand this for your exam. It's really important. Basically, what happens is it splits the list in half and half again until it finds the number. So the list needs to be sorted in the first place. So here's the logic that you're given for this program. And open Q02A and write the program to do the binary search. 10 marks. So this is what you're given, and if you look at that, we're starting at line 11, which matches up with that. Receive item from integer keyboard. So we must write our code there. So make sure you call your variable item. So caps lock off item equals int input, please enter the number to find. So that's the first one done. So now we look at line 12. While start less than or equal to end and not found do, so given a variable called start and end there, so we're going to use those. So while start less than or equal to end and not, that's logical operator there, and not, Boolean operator there, found. So remember, the only thing that's different from pseudocode there is and not are not in capitals in Python, and we don't have do in Python, but we do have the colon. So we've opened up the loop there, while loop, and we now need to go to line 13. Set middle to start plus end divided by 2. So middle equals start plus end / 2. So why / 2? Because that is an integer. We want that to be an integer, not a float. So we put the double slashes in there, otherwise this code won't work. So now we look at line 14. If number list middle is equal to item, then. So our code is pretty much similar to pseudocode here for Python, except we don't have the then and we need the double equal sign, otherwise we're assigning a variable. So if number list middle equals, with a double equal sign, item, press return, 15, set found to true. So here, found equals true. Now we need to do the else, 16. There's my else in there. If item less than number list middle, then for line 17. So that's pretty much similar to the pseudocode, except we don't have a then, we have a colon. 18, end equals middle minus 1. And again, the code is very similar to the pseudocode. And if you have put a colon there and you pressed return, it should automatically indent that for you. So now we're in a nested if, and we need the else. Line 19. Else start equals middle plus 1 for line 20. So that's line 20 done there. Then we have end if, and we don't have that in Python, so don't write end if, and there's no other end if. So 21 and 22 we can ignore. Count equals count plus 1. Now, indentation is really important here. Could easily get this wrong. So, indentation, if you're not sure, get a ruler out and look at that, and it should be on the same line, same indentation as line 16. So there's line 16, it should be on the same indentation as that there. So make sure that it is. If not, move your cursor till it is. So count equals count plus 1. And that does line 23, end while. So that's pretty much it. So we can move this up. Do not add any code below this line, so don't do that. Let's run that and see what happens. So let's put in a number there that isn't there just to test that. So we'll try and find 80. Now this has given me an error, and looking at my code, that should be square brackets, not curved brackets. That was my error there. So run that again. $80 is not in the list. So because I put curved brackets instead of square, it didn't work. Right, that works. So we found a number that, haven't found a number that is in the list. That's good. That condition works. Let's check it. Let's try and find 63 now. Is that in the list? 63 was found in the list. Yeah, it works. So it found 63 in the list. So that works. So just an error correction there on line 14. That should be square brackets, not curved brackets. Okay. So I can close that now. That works. So always test your program. Don't just assume it's going to work. I found an error, a it was actually a syntax error that I put in there, and I only found it by running the code. So always run the code. So that is 10 marks there, and that completes Q02A. B. Figure 3 shows an array of names. So you've got 0 through to 7. You've got 8 elements in this list. This array, list in Python. Explain why a binary search algorithm would not find Juan in the array. Now, if you know about binary search, you might find this a little confusing. You think, well, it's names and not numbers. But what you've got to look at is the first letter of the name. It doesn't matter if it's names and not numbers. That's not the issue. The issue is that the list is not sorted in alphabetical order. So Yekaterina comes before Juan, where it should be what comes first is Christine, as that should be in alphabetical order. It isn't in alphabetical order. That's why a binary search algorithm is not going to find Juan in the array. Not because it's not numbers, it's because it's not in alphabetical order. So here's my answer. The array is not in alphabetical order, so it'd be impossible to find Juan as a binary search algorithm needs lists to be sorted. Now that sentence there would probably be about 2 marks. You really need to explain how it works to get the 4 marks. Looking for a bit more than that. So I've written in this array, Elijah would be compared with Juan. So left side of the array would be discarded. So what would happen is it would start with Elijah and it would think, okay, Elijah is before Juan, so it could discard all the items 2, 1, 0. So 3, 2, 1, 0 would be discarded because it would assume that it's in order, and then Juan would be discarded as well. So it would be impossible to find Juan using a binary search algorithm. C. This is quite a nice question. It should be fairly easy. A merge sort algorithm can be used to sort a list into ascending order. The list there needs to be sorted. Complete the merge sort using the space provided. So what a merge sort does is it splits the list down into single digits. So it split it in half, then half again, then half again till it's down into single digits. Then it will merge them back together again. And as it merges it, it will put them into the correct order. So we'll do that now. So here's the first part. You can see I've split that into 2 parts there, 91763528, and I've made it really obvious that I've split it into 2 parts. So make it really obvious to the examiner. Then we'll break that down again. So now I've broken that down even further. If you wanted to draw arrows coming down from 9176 to 9176, you could do. It's not expected. This is fine as it is. So now we'll break them down into single digits, 9, 1, 7, 6, 3, 5, 2, 8. So that is a split part of the merge sort, and that's probably about 3 marks so far. So now I need to do the merge part. I need to merge the numbers back together. So merge them into pairs. So it'd be 1, 9, 6, 7, etc. So now as I merge them back together, I'm starting to put them into order in their pairs. So now I need to put them into 4s. So it'd be 1, 6, 7, 9, etc. and 2, 3, 5, 8. So now I merge them into 8 digits and they should be in the correct order, 1, 2, 3, 4, 5, 6, 7, 8, 9. And that completes the merge sort. Just make sure it's really obvious in here. Obviously, as I'm typing this, you'll be writing it. Make sure it's obvious that you split that into 4 and then 2s and then single digits, and then you've merged them back into 2s, then 4s, then 8. Just make sure it's really, really obvious to the examiner that you've done that. And that will be the 5 marks. And that completes question 2 for a total of 19 marks. Question 3. Dates are often used in programs. A program accepts the number of a month and outputs the number of days in the month. Open Q03A, the code editor. Use the code to answer these questions. So here is Q03A, and we don't need to save this because we're just answering some questions on the paper. Identify the name of a local variable. So to answer this question, we need to look into one of the subroutines. So we've got one here, def display month number. So I'm going to have that as my local variable, month number. So make sure you do use camel case and you write it exactly as it appears in the question, in the code. so it is month. 2, identify the name of a data structure. Now, you're looking for one of these. This is a data structure, so an array. So I'm going to put my answer there, month and date. And again, we can see we have camel case here. So we must use camel case in our answer. 3, identify the name of a built-in subprogram. So we could use len there. So something like len, that's in purple, or you could have print as well, anything like that. So len finds the length of something, length of an array, for example, length of a string. So that is a built-in subprogram. So I'm going to use len there. 4, identify the name of a user-written function. Well, we've got these here. Show month, name and days. I'm going to use that. So must make sure you use camel case. So that goes there. That is a user-written function. So anything like that that says def is a user-written function. It's not a built-in function. Identify the name of a parameter. Number 5, identify the name of a parameter. So to find a parameter, I'm looking for anything in brackets next to def there. So when we've got the name of our subroutine there, show month, name and days, anything in brackets I can see there, and that is p month, and that is a parameter. And again, we need to have uppercase M. So that is a parameter. It's passed into that subroutine. The subroutine needs p month in order to be able to work. 6, the program includes validation to ensure the month number is between 1 and 12 and inclusive. Complete the table by adding the type of test data that's being used to test the validation. First type of test has been completed for you. So we have typical, erroneous and extreme. So typical is normal, and that would be 3. 3, 4, 5, anything like that between 1 and 12 would be normal. So number 1 would be at the boundary or extreme. So I'm going to write boundary / extreme. Now 15 is completely outside the range by a few numbers. So that is erroneous. So that isn't boundary at all. It's erroneous data because 15 is not within the range 1 to 12. So 1 or 12 would be boundary or extreme, and 15 would be erroneous. So B, explain one reason why parameters are used to pass data into subprograms. 2 marks. Well, it's used instead of global variables because global variables, once you initialize a variable, you start using memory. So to be able to use parameters uses less memory. So a similar argument to why do we use subprograms in the first place? To make more efficient code, to make better use of memory. Using parameters uses less memory because it avoids using global variables. The memory is freed up after the subroutine is finished running. C, this is going to be a program now. 6 marks. A leap year is a year that has 366 days rather than 365. It usually occurs every 4 years. A year that is a leap year can be divided exactly by 400 or can be exactly divided by 4 but not exactly divided by 100. These are leap years 2000, 2012, 2020, not leap years 1700, 1900 and 2021. A program is needed that will accept the input of a year and output whether it's a leap year or not. Open Q03C in the code editor, write the program. You must use the structure given in Q03C. Do not add any further functionality. Save it as Q03C. Finished. Here's Q03C, this is what we've got, and we add our code there. So year equals integer input, so again it's an integer input. Please enter the year in this format, y, so e.g. 2000. Add your code here to display the results. So the variable is called year, so if year, percentage 400, so what this is saying is this is modulo, so if the remainder of when year is divided by 400 is 0, then according to the conditions, we know it's a leap year. So we can print, this is a leap year. So that's the first condition. If modulo, if we divide it by 400 and there is no remainder, so we use the percentage to give us the remainder. If it's 0, then we know it's a leap year. Let's look at the second condition. Or, so this is the elif, can be exactly divided by 4, but not exactly divided by 100. So we'll do that now. So this is the second condition. Else if elif year is equal to 0, so if I divide it by 4 and there's no remainder and year is not equal to, so this is second condition, can be divided by 4, but not exactly divided by 100. So it can be divided by 4, yep, to get no remainder, but divided by 100 is not equal to 0, so there is a remainder, then that's also a leap year. So I can just simply copy that. So this is the AND condition. So both conditions need to be met. So if it can be divided by 4 and come out with 0, but it also needs to be also divided by 100 and the output not to be 0, then it's also a leap year. So what does that mean then with an example? So if we think about a leap year, 2024 is going to be a leap year. So if we divide that by 4, it's 506. But if we divide that by 100, it's 20.24. So it meets both of those conditions. So it's going to be a leap year. Whereas the year 2000 can be divided by 400 with no remainder. There's no decimal point. There's no remainder. So that's the two conditions. And then we need to do the third condition where it's not a leap year. So print year is not a leap year. So that's the else. So let's run that and test that. Well, let's test that with the year 2000. 2000 is a leap year. Okay. Run it again. What about 1999? Could that have been a leap year as well? No, it's not a leap year. What about 2024? Let's test the other conditions as well. 2024 should be a leap year. Is that going to be a leap year? Yeah, it's a leap year. Okay. So that's the finished code for that, using those conditions there and using the modulo, using the remainder to tell me whether I've got a remainder or not, to tell me whether I've got a leap year or not. And that completes question 3 for a total of 15 marks. Question 4a. Programs can be used to manipulate data. Program is needed to convert an 8-bit binary number into denary. Program must. Now here's your bullet points. Now every time you complete one of these bullet points, you can tick it off because you know you're going to get some marks. So it's going to receive the input of a binary pattern and validate that it has 8 characters. So it's an 8-bit binary number. It's going to check that it's got 8 characters. It's not going to check that it contains zeros and ones. It's just going to check that it's got 8 characters. Request it again if it doesn't have 8 characters. So when it's got 8 characters, it's going to convert it into its denary equivalent and print a message that contains a binary pattern and its denary equivalent. Include a comment to explain how the conversion process works. So here is an example. And we've got 8 bits, denary placeholder, binary number. So you can see what happens in this example, and what's going to happen in your program is when we see a 1 in the placeholder, we're going to add that number, and when there's a 0, we're not. So 128 plus 32 plus 16 plus 4, and that gives us 180. So your program's going to do that. Open Q04A in the code editor, write a program to implement these requirements. Save it as Q04A finished. So here is Q04A, and you see what you've got there is an array, a list of placeholders, 128 through to 1. Then you've got a binary pattern, which is a string, denary number 0, and count 0. Add your code here. So the first thing we're going to do, if we go back up here, is going to check, has it got 8 characters? If not, I'm going to ask the user to input again. So make sure you save your code regularly. Save it as Q04A finished, and as I said before, save it in a specific folder because that is going to be what the examiner scoops up at the end of the exam, saves onto a USB stick, or however they've arranged the logistics, but they're going to upload those and going to send those to the examiner. So make sure it is saved in the correct folder as you go. So let's add some code now to check that we've got 8 characters. So we're going to receive the binary pattern and check that it's got 8 characters. So what we can do in this case is use a while loop. So while len, and the variable is called binary pattern, that's the pattern that user enters. So while len is not equal to 8, so while I haven't input an 8 character binary number, we will prompt the user to enter the binary pattern. So binary pattern, make sure you spell it correctly, equals input, and then please input the 8-bit binary pattern, like that. And that's already set to string, so that's going to come in as a string. So that is going to validate the user input, and that is 3 marks because that's done at least the first couple of bullet points there. So now I've got 3 marks for that. So now what I want to do is do the addition and to add up the binary values to give me my denary equivalent. So for digits, a variable called digits in binary pattern. So a for loop to loop through each digit in the binary pattern. You could say for I in binary pattern if you wanted to. So for each digit, if the digit is equal to, and we need to put this in quotation marks because it's string. So if the digit is equal to 1, and it's in quotation marks because it's going to be coming in as a string. So if it's equal to 1, then we'll add that to our values. So denary number is set to 0 at the start, and if they're all zeros, then it will be 0 at the end. But if it's 1, equals denary number plus denary placeholders, the capital P, the camel case, square brackets, count times 1. So it will record that if the digit is 1, it will add that to the count. So e.g., it finds 128, it'll add that to the count, multiplied by 1, 128 times 1, 128, it'll add that to the count. Now we need to increment the count. Count equals count plus 1. So that's done the addition there. All we need to do now is print off the result. So print binary pattern converted to denary is denary number. Right, let's save that and run that. So I input my 8-bit binary pattern. So we use the example that we've got here just so I will know if it works or not, as I'll know if I come out with 180 without me having to add that up. 0, 1, 1, 0, 1, 0, 0. Converted to denary is 180, so that works, and that completes that program, and that is 11 marks. Moving on. B. Open Q04B in the code editor, describe the purpose of the program. So here's Q04B, and we'll run it to see what it does. So run it. Original word is Modnar. No, it is not. Original word is repaper. The word is repaper. Yes, it is. So what is that doing when we look at that? If we look at those two words there, Modnar, that's actually random spelled backwards. Random. So repaper is repaper. So look at those words. R-E-P, R-E-P, A in the middle. It's actually something called a palindrome. A palindrome is a word that read forwards or backwards is exactly the same word, like OXO or ABBA. So the purpose of the program is to check whether the word is a palindrome or not. So remember, a palindrome is the same forwards or backwards, like OXO or ABBA can be read forwards or backwards and it will read exactly the same. That completes question 4 for a total of 13 marks. Question 5. Anne liked to create programs. Open Q05 in the code editor. Contains an array of words. So here's the array of words that we've got in Q05. And what do we need to do? Anne wants a program to accept the input of a word, or number 1 to exit. No validation of the input is required. Display all words in the array that have been the same number as the first word, been input. Calculate and display the number of words in the array that begin with the same letter as the word that's been input. Display all the words in the array that contain the word that's been input. Calculate and display. And then 3 bullet points here. The number of words in the array that contain the word that's been input. The number of letters in the longest word that contain the word that's been input. The number of letters in the shortest word that contains the word that's been input. Display the longest word that contains the word that's been input. The shortest word that contains the words that have been input. Repeat until the user inputs 1 to exit the program. So here's the demonstration of what needs to happen. So I enter a word, window. So here's the 2 words. So display all words in the array that have the first letter, wind and wire. 2 words begin with W. There were 0 words with all the letters from window in them. End of program. So it hasn't found any words in there, and that's what it needs to do. So if we try another word, a shorter word like win, we found wind and wire. 2 words begin with W. Found the words that contain win, wind, borrowing, swing. 3 words with the word win in them. Longest word has 9 letters, shortest word has 4 letters. Longest word is borrowing, the shortest word is wind. End of program. So that's what our program should do. Now, the best tip I can give you for question 5 is it's going to be hard. You might not complete all of it, but every bullet point that you complete is going to get you marks. So if you're not the world's best programmer, and there's plenty of people in that boat that would say they're not great, just remember, you must have a go at this program. It's not that hard. It shouldn't be that daunting. And each bullet point that you get to work is going to give you marks. So you need to have a go at this. And what you need to do is to get a bullet point to work, save it, and then move on to the next bullet point. What you shouldn't be doing is sitting down and trying to write the whole lot, unless you really know what you're doing, and then saving it and running it and find parts of it don't work, some of it does work. Complete it bullet point by bullet point. As you get the bullet point to work, save it, and then move on to the next bullet point. So first thing we're going to do here is accept the input of a word, or number 1 to exit. No validation of the input is required. So the first thing I've done is created some variables called shortest, longest, shortest word, and longest word. Shortest is set to 5,000. I'm going to loop through each word and I'm going to find the shortest word. And if I set that to 0, then that will always be the shortest word. There won't ever be a word shorter than 0. So if I set that to a big number there, then every word that I find from then on is going to be the shortest word in my loop as I loop through. Longest is set to 0. That needs to be 0 because if it was set to 5,000, then there'll be no words that are ever bigger than that. So we set that to 0 at the start. Shortest word is a string. Longest word is a string. So now I'll create a variable called input word equals input. Please enter a word or 1 to exit. And that's going to automatically default to a string because that's the default data type. I don't need to do anything there. So enter a word or 1 to exit. And by the way, we'll accept 1 as a string. So if the user inputs 1, the program will stop. Now, to get the top band, mark band here, you must comment the code. So what we're looking for is code is clear and readable. And one way to do that is to comment the code. And you must comment the code to be able to show the examiner what you've done and to show that it works and show you know what you're doing there. So you add comments into the code in order to be able to get mark band 3. So you must have comments in the code. Without comments in the code, you cannot possibly expect to get into mark band 3 to 7 to 9 marks. So the way this is marked is there are a total of 11 marks for getting parts of the code right. And there is mark bands 1, 2 and 3, looking at how you program basically. Do you add comments to the code? Is it logical and clear? Does the program fully meet user requirements? So commenting the code is one way we've got to make sure that we're able to tick those boxes in mark band 3. So we're going to check to see if the word has the same letter. So if the input word is not equal to 1, so only if the word input is not equal to 1, so if it is equal to 1, then the program will stop. If the input word is not equal to 1, now we can do our check. We set our count to be 0. We need a count, and for word in word array. So for each word in word array, I'm going to loop through each word and do my checks. So if word 0, so the word, element 0 of the word is equal to input word 0. So we're checking the first letter of the word. If they're the same, then we're going to say they have the same first letter. So we're going to print that word and we're going to add 1 to the count. So now I can print off the results of that. I'm going to save it as Q05 finished and run it to see what happens. So I've run that and I've got 2 words beginning with W. I know that works. So I can tick that box. I've done actually 2 things there, that one and that one. Now if I'm just looking at the mark scheme now, 3 variables initialized appropriate, word input, repeats until 1 is input, loop for each word in the array, check words begin with same letter, number of words begin with same letter displayed. I've actually got myself 6 marks for that. So in terms of bands, Probably not. If that's all I've done, I'm probably not going to get in beyond mark band 1 really, because it's not really, it meets some of the requirements, so it's mark band 1. But say I've got 2 or 3 marks for that, added to the 6, that's 8 marks out of the 20. That's not bad. I'm almost at halfway point. Okay, so I've done that. I've got that to work. That's great. Now I can move on to the next one, and I can have a look at the next bullet point. So I've done 3 there. Display all the words in the array that contain the word that has been input. That's going to be my next thing to. So again, I'm commenting my code, and I'm commenting my code to show the examiner where the bullet point is that I've done. So I'm making the examiner's life easy. Why do I want to make the examiner's life easy? Because they're the ones that's giving us marks at the end of the day, and they're the ones that are going to decide whether I pass or fail this exam. Okay, so I want to make their lives easy. They've got 200 or 300 of these to mark. I want to make their life as easy as possible to show them that I've done this. Give me the marks. I've achieved this. You can give me the marks in safety, and you know exactly what I've done there. So now I'm going to find words that contain the input word. That's going to be my next thing. That's the next thing on the bullet points I'm going to do. So now I've initialized a count to 0 for word in word array. For every word in the array, I'm going to loop through that. So check to see if the word contains the input word. If input word in word, if that's true, I'm just going to move this down to give me a bit more space there. Add 1 to the count, print the word. Now I'm setting the length of the word. Length equals length len, using built-in function len to check the length of the word. So now I'm finding the length of the longest word. If longest is less than length, longest equals length of the word, and longest word is equal to that word. Now let's find the shortest word. If shortest is greater than length, shortest equals length, shortest word equals word. So now we're finding the shortest word there. So if the length is shorter than the shortest, replace it and the shortest word. So if the length is shorter than the shortest, replace it and the shortest word. So if it's shorter than the shortest, then that's going to be the shortest word there. Okay, that's that done. Now I need to print out these outputs. So now, if count is greater than 0, print count words with input word in them. So it'll print how many words with the input word in them. The longest word has longest letters, shortest word has shortest letters, longest word is longest word, shortest word is shortest word. If count isn't greater than 0, so if it hasn't found any words at all, there are 0 words with all letters from input word in them, and then end of program. So let's test that out. So we'll run the program. Let's test drum. 0 words begin with D, 0 words with all letters drum in them, end of program. That works. So now let's try win. Borrowing, wind, swing. So his longest word has 9 letters. So that is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep, that's correct. Shortest word has 4 letters, W, I, and D. Remember, it's not going to be win, because win isn't in the array. It's going to be wind. That's the word that's in the array. So wind is the shortest word. Longest word is borrowing. Yeah, shortest word is wind, end of program. So that works. And that completes that program. So that is the whole of the code there completed. Okay, so that's that done. You can do some planning, design work on this page. You will not get marked for it. You can make notes there. I wouldn't recommend spending hours doing flowcharts. Maybe you can write some pseudocode if you want to. What are my top tips for this question then? This is going to be the hard one. So question 5, or if there is a question 6, is going to be the 20 marker at the end of the exam. Top tips then, break it down bullet point by bullet point. Get bullet points to work. Get a bullet point to work. You know you're going to get some marks. Get another bullet point to work. Save it before you move on to the next bullet point. Do not try and complete all the bullet points unless you really know what you're doing. And then save it and run it and find that there's problems. Do it bullet point by bullet point. Get it to work. Break it down. Show the examiner you know exactly what you're doing by commenting the code. You can add as many comments as you want to this program. Make sure the comments though link to the bullet points. So every time I've completed a bullet point, I've written a comment to show the examiner that I've done that. That's the code there. Add more comments as you want to point out things to the examiner. This is for the examiner that you're commenting the code. So things that you want to point out to the examiner, show them. So if you tried to complete part of the code and you didn't get it to work, I'd still leave that in there. I'd maybe comment it out, or write a comment to the examiner. This was partly completed code. Unfortunately, it did not work. Main thing is that you have a go at question 5. Even if you're not a great programmer, you still need to have a go at question 5. And you get marks by breaking it down bullet point by bullet point. And that's how you're going to get marks from this. You're not going to get marks from doing the whole lot. It's not broken down like that. The mark scheme breaks it down quite clearly. Every one of these bullet points that you do, that you get right, you get marks for. And you also get marks for commenting the code, making it clear and logical. Sensible variable names, good use of white space will also give you points because there's marks for coded clear and readable as well. In terms of meeting requirements, for Mark Band 1, meets some of the requirements. Mark Band 2, 4 to 6 marks, most of the requirements. Mark Band 3, fully meets the requirements. So you know that if you complete all of it, you're going to get into Mark Band 3, 7 to 9 marks. So have a look at the mark scheme. I'll link it in the description in this video for you to have a look at how you're going to get your marks. But there's 11 marks for each completed part of the program and then marks for how you code. So remember, comment the code, break it down bullet point by bullet point so that you know that when you've achieved so many bullet points, you're going to get so much marks. Okay, that's how it works. So do your best, take your time. I would allow, if you can, this is a 3-hour exam, I'd possibly recommend to allow an hour if you can. Now that completes the paper, the 2021 November Paper 2 for Computer Science. Thank you very much for watching to the end. Good luck in your exam. If you did watch it to the end, please leave me a comment in the description, down in the comments section. Let me know that you've watched it to the end. I'll be really grateful. Please let me know how you get on. And best of luck with your exam. See you in the next video. Bye bye.